Our climate is changing. Across the world, there is scientific consensus that the global temperatures is rising dangerously fast due to a high increase in greenhouse gas concentration. Carbon dioxide levels have risen by 40% since pre-industrial times, primarily due to human fossil fuel emissions. It is clear that something drastic has to change in order to prevent a global catastrophe, but cooperating to reduce our greenhouse gas emissions fast enough is far from easy. Could we combat climate change another way? People may ask why, when things are already being done to take action against climate change, we need to consider climate engineering. At the moment, our solution to climate change is reducing our fossil fuel use and therefore CO2 emissions. However, for the scale of the problem, the necessary reductions would have a dramatic effect on normal life. Can we ever create targets that are both drastic enough to combat climate change but realistic for the world to follow? Climate engineering could reduce the need to lower emissions by providing another alternative. This could lead to much more realistic goals in CO2 reduction.
Solar radiation management projects are a method of climate engineering which aim to reduce the amount of sunlight that's absorbed by the Earth and its atmosphere, thus reducing the effect of global warming. Advantages of this technique of climate engineering include their low financial cost and the speed of which they can be implemented. A prime example of an SRM project is the deployment of stratospheric sulfate aerosols. Sulfur within the atmosphere reacts with water vapour in order to produce tiny droplets of sulfuric acid which scatter the light entering the atmosphere. This method has proven to be highly effective as, to quote the Council on Foreign Relations, 1 kilogram of well-placed sulfur within the stratosphere would roughly offset the warming effect of several 100,000 kilograms of carbon dioxide. Another example of atmospheric solar radiation management is called cloud reflectivity enhancement. This method involves the use of modified rotor ships to spray tiny droplets of seawater into the sky, which then turn to vapour. The increased concentration of vapour within the atmosphere thickens and whitens clouds, causing them to become more reflective. If implemented correctly, then this method is said to be effective enough to reverse the warming effect of a doubling of CO2 levels.
One of the world's most hazardous greenhouse gases, CO2, plays a vital part in plant and animal life on Earth. However, the sheer increase of CO2 output in the last century has caused CO2 to become the primary cause of global warming. It plays a massive role in regulating Earth's surface temperature through radiative forcing and the greenhouse effect. Carbon dioxide removal, also known as CDR, is a series of techniques that can be used to essentially solve this problem. One of these methods is known as biochar. This is the name for charcoal that is being used for specific purposes such as removing carbon from the atmosphere. It is created using thermal decomposition of biological material. Instead of releasing CO2 into the air how normal biomass would when burnt, biochar can hold a massive amount of carbon without releasing it back into the atmosphere for hundreds of years. Biochar can then be used as a fertilizer, and so it has additional uses.
One method, known as enhanced weathering, is similar to biochar. Rocks such as the ultramafic rock are chemically used to hold thousands of years' worth of carbon emissions for a massive amount of time. Another alternative method is ocean fertilisation, which is when extra nutrients such as iron are added to the oceans to increase the phytoplankton count, because they take in a lot of carbon and take it down to the seabed when they die. These methods have not been put into practice yet, so economically they could cost a massive amount of money, and along with not being able to accurately predict how well they would work, it is difficult to judge whether it is an efficient response to climate change.
Solar radiation management techniques, which reflect a small percentage of the sun's light and heat back into space, only reduce some, but not all, effects of climate change, while possibly creating other problems. They also do not affect CO2 levels and therefore fail to address the wider effects of rising CO2 levels, including ocean acidification and changing the habitats of land and marine life. Termination shock is abruptly stopping solar radiation management, and it would cause the climate to warm rapidly. If climate engineering is discontinued at any time, extremely rapid warming occurs, up to 0.36 degrees per year, along with an increased rate of atmospheric CO2 accumulation. At this level, expected within 40 years, the hot European summer that occurred in 2003 will be the annual norm. Furthermore, in CO2 reduction techniques, biochar is used as a special soil to absorb surplus CO2, But once this greenhouse gas is stored in this substance, what happens next? Does it decompose to re-release CO2, or will it stay stored there forever? One of the biggest issues with any approach to climate engineering is funding. Most projects are extremely expensive with small benefits that may occur, and so many companies therefore are not interested until the technology is 100% effective or proven. To conclude, climate engineering could undoubtedly positively influence our life as a whole on Earth by CO2 reduction and radiation management.
However, if this plan is not conducted effectively, whether it is the technology, science, funding or governing, it could also prove detrimental to our beautiful planet.